Welcome to this explainer. Let's just jump right in. Today, we're stripping math down to its absolute bare-bones foundation. You know, if you've ever felt completely overwhelmed by complex formulas or massive data sets, it's usually just because the basic structural integrity of the math has gotten, well, a little fuzzy. So we're going right back to the raw numbers, the core operations, and the really beautiful, undeniable logic that holds the whole thing together. Think of it as a masterclass in the grammar of numbers.
Here's our agenda for today. We'll be looking at the world of whole numbers, core arithmetic operations, solving for the unknown, rounding and estimation, and finally, the basics of statistical analysis.
So part 1, the world of whole numbers, building the foundation.
Okay, to build our mathematical house, we really have to understand the building blocks. And that means starting right at ground zero and defining our terms. So what exactly are whole numbers? Simply put, they're the positive counting numbers, like 3 or 356, along with the number 0. There are absolutely no fragments here, so no fractions like 1/2, no decimals like 0.75. They are complete, solid units. Now, when you take those whole numbers and you include their exact opposites, the negatives, you get what we call integers. So +5 and -5 are both integers. Simple enough, right?
Now, visualizing this is super helpful. The number line perfectly maps out how these integers relate to one another, and it extends infinitely in both directions. There's a really strict absolute rule here. As you move to the right, the values increase, so +4 is less than +5. Makes sense. But as you move to the left, the values decrease. It can feel a little counterintuitive at first, but -4 is actually greater than -5, just because it sits further to the right on this line.
To actually talk about these relationships on the number line, we use specific symbols to create number statements. The equal sign is pretty straightforward, right? It just means the values on both sides are exactly the same. But the other two are where our number line logic really kicks into gear. The greater than symbol points to the right, and the less than symbol points to the left. A great little trick to remember this is that any integer is always greater than the integer to its immediate left on the number line.
Moving on to part 2, core arithmetic operations, the mechanics.
All right, now that we have our building blocks, let's really dive into the mechanics of our mathematical house. This is where we take those static integers and actually make them interact, starting with addition. Addition is, of course, just combining two or more numbers to find a sum. But what happens when things get a bit too big? Well, we use carrying. You always want to set your problem up vertically, making sure to align the rightmost numbers. If a column adds up to a 2-digit number, so anything more than 9, you just write down the right digit and you literally carry the left digit to the top of the next column to the left. Then you simply add it into that new column.
Adding 37 and 25 is a really great example of this. So, starting in the right column, 7 plus 5 equals 12. Well, 12 is way too big for one column. So we write down the 2 and we carry the 1 right to the top of the left column. Now, for the tens column, we just add that carried 1 plus 3 plus 2, which gives us 6. Our total sum is 62. Seeing it structured vertically like this just makes the logic entirely foolproof.
Okay, let's move over to subtraction, which is literally just taking one number away from another. Again, we line our numbers up vertically and right justified, and we work from right to left. But what if the number on top is smaller than the number on the bottom? I mean, you can't take 5 away from 1. That's exactly where borrowing comes in. You just look to the column to the immediate left, borrow 1 from it, and add it to your current working number. You just have to make sure you reduce the neighbor you borrowed from by 1. Let's look at how elegantly borrowing solves a tricky problem like subtracting 65 from 381. On the far right, we instantly hit a wall. We can't do 1 minus 5. So we look to the left, to the 8. We borrow 1 from that 8, leaving it as a 7. That borrowed 1 turns our original 1 into an 11. Now the math is super easy. 11 minus 5 is 6. Moving left to the tens column, our new 7 minus 6 is 1. And in the hundreds column, well, 3 minus 0 is just 3. So we end up perfectly with 316.
Shifting gears to multiplication now. Honestly, the most important thing to realize about multiplication is that it isn't some brand new, isolated, complex concept. It is literally just a shortcut for repeated addition. 5 times 3 is really just 5 plus 5 plus 5. And a classic multiplication table organizes all these predictable patterns. By finding the intersection of a row and a column, you instantly find the sum of that repeated addition without having to manually count the whole thing out. It's a massive time saver.
The final core operation is division. Division is basically the exact opposite of multiplication. It's the act of splitting numbers or amounts into equal, smaller portions. To really master this, we need to know the anatomy of a division problem. The dividend is the large starting number that's going to be chopped up. The divisor tells us the size or the number of those chopped up portions. And the quotient? Well, that's your final answer.
Let's apply those terms to a real problem. Say we're asking how many 3s are inside of 81. The 81 sits under the bracket, so that is our dividend, the number being divided. The 3 sits on the outside. That's our divisor, the size of our portions. And sitting proudly on top is 27, our quotient, the final answer. Understanding these labels really keeps you from setting up complex problems backward.
All right, section 3, solving for the unknown, understanding relationships.
Once you really understand the core mechanics, you start to realize math isn't just a one-way street. The relationships between addition and subtraction, or multiplication and division, are totally fluid and reversible. And we can use that reversibility to find missing information. Here's a fun little thought experiment for you. We have a blank space. Plus 12 equals 75. So something unknown when added to 12 gets us to 75. How do you go about finding that missing piece without just guessing randomly?
Well, the answer is 63. But the absolute crucial point here is how we got there. Because addition and subtraction are exact opposites, you can actually solve an unknown addition problem by subtracting. If you take the total, 75, and subtract the known part, which is 12, you're left with exactly 63. You literally just reverse the operation to reveal the unknown. It's like a math magic trick.
Moving along to section 4, rounding and estimation, finding the general answer.
In the real world, you honestly don't always need an answer down to the exact decimal point. Sometimes you really just need to know the general neighborhood of a number to make a quick decision. That's exactly where rounding comes in. It reduces the digits in a number while keeping its overall value highly similar. And the rule is brilliantly simple. Just locate your target number and look immediately to its right. Take 7,872, for example. We want to round to the nearest hundred, so our target is the 8. The number to its right is 7. If that neighbor is 5 or more, you round your target up. Since 7 is greater than 5, the 8 becomes a 9, giving us 7,900. Now compare that with 7,842. The neighbor next to the 8 is a 4. Since 4 is less than 5, you just leave the target number alone, rounding down to 7,800. It's a really quick mechanical rule that makes estimating an absolute breeze. And our final section, Part 5, Basics of Statistical Analysis, Processing the Data. Once you're comfortable with numbers and operations, you can actually start processing massive amounts of data to find overall trends. This is where math really starts explaining real-world behaviors. One of the most useful statistical tools out there is the arithmetic mean, which we more commonly know as the average. An average basically takes a scattered group of numbers and synthesizes them into a single representative number. It's a super straightforward two-step process using the operations we literally just reviewed. First, you add all the individual units together to find their total sum. Second, you divide that total sum by the number of units you just added. That's it. Let's see how this builds using a really practical example. Imagine a student with 5 test scores, 92, 79, 100, 89, and 95. Step 1, we add them all up. Doing our vertical addition, we get a total sum of 455. Step 2, we take that 455 and divide it by the number of tests, which is 5. 455 divided by 5 lands us perfectly at a 91. That single number, 91%, accurately represents the general trend of all 5 of those distinct tests. Pretty cool, right? And that brings us to the end of our explainer. I really want to leave you with this thought. How will mastering these absolute foundations of numbers transform the way you navigate your daily life? Because when you strip away the fear of math and you look at it purely as whole numbers, logical number lines, and reversible operations, you aren't just memorizing abstract formulas. You're unlocking a real-world toolkit to estimate, solve, and analyze any data the world throws at you. Thanks so much for watching, and keep exploring the logic around you.